What's going on, everyone? In today's video, I'm going to show you the product rule of exponents, as well as 3 different problems, one easy, one medium, and a hard one. Let's get to it. If you ever look up the product rule in a textbook or Google or something like that, you're probably going to find something pretty similar to this. You're going to see a letter to a different letter times that same letter to a different letter equals all this stuff. What does that actually mean? Well, what this means is that if we have a base, and that's what this is called. It means like a number that is the same here and the same here. Could be 2, could be 3, could be 17, could be -4. Is raised to some exponent, x and y, and we're multiplying them together. Well, then the way that we solve that and simplify that is that we write it as one of those bases, one of the numbers, to the power that is the sum of their exponents. Okay? Now, why is that the way that it is, and what does that actually look like? Well, let's say we had 2 to the power of 3, and let's say we had 2 to the power of 4. So does this follow the same format? Sure, I have the same letter and the same numbers in that placeholder. So my base is 2, my exponent is 3 and 4, okay? So the reason that this property works is that, let's say I actually just wanted to expand this out real quick. So 2 to the power of 3 would just be 2 multiplied by itself 3 times, times 2 to the power of 4, if I wrote that out, it would just be 2 times itself 4 times. And if we actually wanted to rewrite this as an exponential form, well, think about this. I have 1, 2, 3, 4, 5, 6, and 7 total 2's that I'm multiplying together. That's going to be equal to 2 to the power of 7, which is the same exact thing as those exponents added together. So, in summary, the product rule of exponents, if you have some number here and that same number here, known as the base, all you have to do is take those exponents, add them together, and that's your new exponent for that same exact base, and there's your answer. And that shortcut works every time. Let's take a look at an easy problem. Okay, so let's say we have 3x times 2x. So a lot of times, some students get hung up on this because, well, they're like, well, there is no exponent, and that's not true. Whenever you see an x or some kind of variable written like that, it's technically to the power of 1. So maybe if I rewrite it like this, it might help you out a little bit. Okay, so let's think about this. Coefficients always get multiplied together, so 3 times 2 would just be 6. And now I have x to the 1 and x to the 1. So x is going to be my base, and then the 1's are going to be my exponents. So I can rewrite that as x, and I know that it is. So I have 6x and to the power of 1 plus 1, the sum, that's going to be 6x squared, and that is my final answer. So 3x times 2x, 6x squared. Let's take a look at a immediate problem. So as you can see here, I just have a coefficient 3, x cubed, y to the 4th, then in parentheses, negative 14x squared, y to the 5th. So that might seem like a lot more, but really it's just the same property done a couple times. So how do we solve this? Let's rewrite this as 3x cubed, y to the 4th, times negative 14 x squared, y to the 5th. Now let's combine like terms. So I have 3 times negative 14. What's that going to be? That'll be negative 42. Okay. Now I'm going to have x cubed and x squared. So I know I can rewrite that as x to the power of 3 plus 2. Then I have y to the 4th, y to the 5th. That's going to be y to the 4 plus 5. Simplifying that down, I'm going to have x to the 5th, y to the 9th. There it is. So as you can see, even if things get a little bit more complicated, as long as you just stick to the fundamental rule, you'll be fine. Now let's take a look at a harder problem. All right, so as you can see, this one looks, harder. So we have 3a to the 1/2 b squared times 3a to the 5 over 4 b to the 1/2 times a to the negative 3 over 2 b to the negative 1/2. Whoa. So, wow, where to start, right? Well, you should probably already know that from the examples we've done before, all you need to do is take the step-by-step, combine the like terms, and you'll find an answer. So let's do exactly that. Now, let's focus on how to break this down a little bit easier. So let's focus on this term and that term. Okay, so let's just combine the like terms that we have. So I have a 3 and a 3, 1 3 here and 1 3 here. That's going to make a 9. Then I'm going to have a to the 1/2, a to the 5 over 4. So that's just a to the 1/2 plus 5 over 4. Then I have b squared, b to the 1/2. So that'll just be b to the 2 plus 1 over 2. And now let's write this other term, making sure that we keep it in our work. A to the negative 3 over 2, b to the negative 1/2. Okay, so now let's simplify this down. I already had 3 times 3 was my 9. Now I have a to the 1/2 plus 5 over 4. That's going to be a to the 7 over 4. B to the power of 2 plus 1/2. That is going to give me 5 over 2. Okay, so now I simplified that. I can just rewrite my next term down here. A to the negative 3 over 2. B to the negative 1/2. And repeat the same exact thing. Okay, technically speaking, there's going to be a 1 in front of here, but we just don't write that. So my 9 is going to stay exactly the way it is. I have a to the 7/4, a to the negative 3 over 2. So I just have a to the 7 over 4 plus a negative 3 over 2. I have b to the power of 5 over 2 plus a negative 1/2. All right, and now I'm almost done. So I'm going to drop my 9 down again. So I have 7/4 plus negative 3 over 2. So that's really 7/4 minus 3 over 2. That's going to give me 7a to the 1 over 4. Then I'll have b to the 5 over 2 minus 1 over 2. So what that's going to give me is 4 over 2. And let me simplify that one step further. 9a to the 1/4, b to the power of 2. And that is going to be my final answer. So as you can see, even when things get a lot longer and more complicated looking, as long as you use that same fundamental step, you're going to get the right answer every time. Thanks for joining me today. I really hope that these 3 examples helped you out. If you have any questions, drop a comment down, hit like and subscribe, and we'll see you in the next video. Take care.